Hi, everybody. This is the Hungry Math Professor here, and thanks for coming to my channel. Today, I want to discuss something slightly different than my normal discussion, but it's going to be in mathematics, and I want to discuss some current research. And for those of you who don't know, when you're working on a math research paper, a new research result, when you are done with the final paper, the first thing that you do, in my area at least, is that you post it to archive. So when you post it to archive, it's just a free place that you can post it. It doesn't mean that the results are correct. It just means that from your point of view as the author, you think it's correct and you think it's done. So you post it to archive, and now everyone can look at it. And then I usually post it, or I usually submit it to a journal within that week that I posted it to archive. And then you wait for it to be, reviewed by referees, looked at by an editor, reviewed by a referees, you get your reports back, blah, 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 blah. But that can take a long time, right? Like the shortest it's ever taken for me is maybe 4 months, and the longest it's taken is ridiculous, like 3 years. But on average, it's usually around a year for me. So that's part of why we post things to archive, because the author thinks it's correct and done, and now other people can basically, if they want to use my result, they can certify themselves that it's correct by reading it carefully and then use it, or they can cite it because it's related to something they're doing. And so this is just kind of how the community works, and we're very comfortable with this at this point. Not every math research area, in my understanding, does this the same way, but most of the areas that I'm aware of do it this way, especially geometric analysis for sure, which is my research area. Now, where this gets interesting is that recently, last week, there was a paper posted to archive. Let me show you the paper because we're going to look at it. This happens all the time. Papers are posted to archive. I follow the differential geometry, subfield on archive. And so archive sends me an email every morning with all the papers that were posted in differential geometry from that day. Now, the reason why I didn't see this paper is because it was posted to GRQC, which is General Relativity and Quantum Cosmology, which I have posted some of my papers in that subfield because on archive you can cross list. So sometimes I will post a paper to differential geometry and cross list it with general relativity and quantum cosmology because sometimes my research is related to general relativity. Now, this paper crossed my eyes and my collaborators, as well as many other people in my field, pretty quickly because it says that it's giving a proof of the spacetime Penrose inequality, which if anyone gives a proof of the spacetime Penrose inequality, you're going to perk up a lot of people's ears because this is a big deal and we'd be surprised. So, people want to read a paper that says that they proved the spacetime Penrose inequality. And it's by an author that I've never heard of, which is unlikely because if anyone's proved the spacetime Penrose inequality, I expect to know who that person is. I may not have ever met them, but I've probably read a paper by them. Unless they're a grad student, or a new postdoc, in which case I would know their advisor. Like that's just likely to happen because I'm in this area, I've worked on this problem. And so it's just, these communities in mathematics are quite small. It's just unlikely that whoever, proves this result is someone I don't know of in any way, shape, or form. I at least know their advisor. Um, but surprises happen, right? We don't want to be so skeptical that they were not open to the, history is full of surprises. So who knows, right? So you see this paper, my collaborator brought this to my attention. We were meeting last Friday with the four of us, and we were looking at this paper. So you say, okay, well, let's see, right? Now, one of the first things that we noticed about this paper is it's 200 pages long, which is a crazy long math paper. Are there math papers 200 pages long? Yes, but they're always met with a little bit of skepticism because it's just, it's a ridiculously long paper. Then again, this is a very difficult result. So if you came up with a completely new approach, you may need to like establish many new um, technical things that could cause you to write a 200-page paper. So again, we don't want to be so skeptical that we can't allow for surprises. And in the stability of like black holes community, it's not on there is legitimate papers of this length. So it's rare, but it's not so rare that we should immediately discount it. Okay, so let's take a look at this paper then, right? So we start looking through the paper. It's 200 pages long, so it's helpful to have this table of contents. We're happy. One weird thing is there's so many appendices. Again, that doesn't discount the paper, but it is certainly unusual. And there's lots of unusual markings here because there's just so much of these bullet points that, again, people could just choose to write differently than the community tends to, but there's just way too many bullet points for like what I'm used to from most mathematicians that I know. You know, maybe this is helpful to have these acronyms and abbreviations. So again, this doesn't immediately discount it. Perhaps they just think this would help to make it easier to read. But again, it is quite unusual. Uh, this is also a little bit unusual. This is the kind of thing you see in abstract algebra, like a commutative diagram. And here it's not playing the role of a commutative diagram. Um, so, it's not enough to cause me to call this nonsense. But the first thing I want to look at now more seriously is on page 19. So let's skip there. So here's where we see the main theorems. Okay, so this is the space-time Penrose inequality. Now the problem is, well, there's two main theorems, and they're both incorrect. The second one is more offensive than the first, but they're both incorrect. Okay, the first one looks pretty good. I don't want to get into the technical details because if you don't know what the space-time Penrose inequality is, you're not going to follow everything what I'm saying. But it is true that, just to give you a general idea, when you have a black hole, you want to look at this whole system that maybe has lots of planets, has lots of black holes, lots of other things in this universe, and you can measure in some way the total mass contained in the entire system. That's what's being used as the capital M here. And then there's a conjecture inequality, which is really beautiful, which says if you want a lower bound on that mass, because maybe you can't measure the mass of everything in that system, if you just want a lower bound on that mass, say that it's bigger than or equal to something, then just look at the area of all the black holes that are in your universe, sum up the area, and form this square root of the area over 16 pi. That will give you a lower bound for the mass. So this is generally correct. The problem is we know now that it's a little trickier than that because you have to take these apparent horizons and then you have to look for the outermost minimal area enclosure. Let's not worry about exactly what that means. The point is that this statement is slightly incorrect. And actually, part of the reason why me and my collaborators were so interested, also because we're in this area, but we also recently posted a paper where we don't prove the space-time Penrose inequality. We prove it with a suboptimal constant. Okay, and I'm only bringing this up because, well, for one, we've proved something related that was much weaker, and we were also proud of it because of how little progress has been made in the general result. But I just want to show you what the result should look like. It looks almost exactly the same. The difference is that you have to take the minimum area required to enclose the outermost apparent horizon, not just sum the area of the outermost apparent horizons. Because in the general case, you won't get the right answer if you just sum the area of the outermost apparent horizons. You have to take the minimum area enclosure. And just to point out, what we were able to prove is something much, much weaker, unfortunately, where we have this ginormous constant. And so it's not the right constant, So we get this very general result. What we like about this result is that it holds for general initial data, like the kind of things that it should, like the full generality that it should hold for. But, the constant is way off, right? But just to kind of point out how surprising it would be if someone proved the entire thing, but also to point out what the statement should look like and why it's wrong. But the second statement's even more offensively wrong, because in the second statement, the same issue with the sum of the areas things, but let's move on from that part. The offensive part is to say it says possibly unstable horizons. That is well known that that's not true. In fact, they're just like very simple pictures that everyone in the community knows, even people who aren't interested in working on this problem, but have seen like a talk on this problem, know that that's not going to work. It's just obviously false. So that's bizarre, right? And this is when you start thinking, was this paper generated by an AI? Because again, if you Google this mathematician, they don't exist. There's someone else with this name, but again, that's not surprising in mathematics to have another Chinese mathematician with the same name. And they're not in this area. They're in like numerical analysis. So I don't want to throw them under the bus. There's no one else in this that like no one comes up that seems to be producing this paper. So perhaps this person is made up a fake name. They don't want to know. They don't want people to know who they are. Are they trying to mess with us? I don't know. But this theorem is clearly wrong, and that calls into question um, like some of these lemmas are very obviously wrong too. And I'm not going to go through all the details now, but we do want to just kind of note some of the other bizarre features that make it seem clear that this was generated by AI. So let's go to page 59. Okay, now this picture is actually extremely reasonable for this paper. So it's in the right, like this could be an image in one of my papers and one of my collaborators' papers or something. But there's a glaring issue, which is this word overruns the image in a way that I would never post to archive, right? Okay, let's keep going. Page 81. Similar nonsense. Like no human is going to let that arrow stay like that. It's ridiculous. It's actually kind of surprising that an AI system wouldn't fix that. But, you know, I guess if you ask an AI system to generate 200 pages, you know, it can only, it depends on how much time you give it or how much time you ask it to work on how well it's going to do. I don't know. This one is not so egregious, but still overruns a little bit. Let's just go to 106. But you kind of get the idea, right? There's just lots of these weird issues where like humans would just move this text over or move this text over. There's plenty of room just to move it over. Um, Weird, right? And we don't need to go through all this, but again, throughout the paper, there's lots of bullet points, which is also just bizarre. That, you know, the mathematics looks like the right kind of mathematics. I mean, if I look at the details, I'm sure there's all kinds of things that don't make sense. But why so many bullet points? Like that's the kind of thing that you expect, you know, one of these large language models to do and not a human to do. This is way too many bullet points for a professional paper. I just don't understand um, what's going on there. And, you know, again, it's 200 pages and it's missing, I mean, it's missing our paper, what, you know, whatever. But any human who's in this area would have seen our paper. Like they may not, yeah, I'm not saying it's such a great paper or anything like that. I'm just saying they would have been aware of it and they would have cited us just because why not? You know, you cite everyone who's done something relative to this result. And what we did is certainly relative. And for a result of this size, this conjecture has been around for so long. 41 citations is quite short for such a monumental paper. Now, what's interesting about that last detail is I noticed that this paper was reposted. So on archive, you can keep reposting papers anytime like you find a mistake, you find typos, whatever, you can repost as many times as you want. Generally, we don't want to repost too many times because it starts looking suspicious, but you know, there's no like magic number of like you shouldn't repost more than this many times. You can repost as many times as you want. So this paper was reposted a second time, which is not weird in and of itself. It was posted first on Wednesday, December 3rd, and then it was reposted on Saturday, December 6th. I will say this is actually not that unusual because it's not crazy unusual for you to post a paper to archive and have someone in your field see it and notice something small that you should change. Or, you know, also when you post this paper to archive, you tend to have like this anxious moment the next day, like, did I make a mistake? So you might find like some small mistake, or you might even find a big mistake, like, you know. Anyway, that in and of itself is not weird. They changed the name of the paper to the unconditional spacetime Penrose inequality. As far as I know, this is not a thing that we don't have a name for, as far as I know, the unconditional spacetime Penrose inequality. So now we look at this paper. So now this paper has a longer abstract. He took away his affiliation at the top. I mean, just little kind of things that I don't want to harp on too much. This is a different format now. It's not blue, like, you know, this is way longer because the paper now is 442 pages. What the heck? That's unusual. So when you repost, you might change the page number. Right? I'm not saying pages change, but it's really weird to go from 200 pages to 442 pages in a couple of days. What the heck? You don't just produce 242 pages unless you ask a large language model to do it again. I don't, you know, like I don't understand. And that 442 pages is ridiculous length. That no serious mathematician is going to take this seriously. I mean, it's not impossible, but I mean, again, there's some weird stuff already. Like, why is this overrunning this stuff, right? I don't want to look at this one too closely because we're already like pretty convinced that this is garbage. Um, but they do, what's weird, another thing that's weird is that like okay, when you repost a paper, generally you just make minor changes, or if you'd even make a big change, you're not going to completely rewrite the paper. You're just going to change a section or fix typos or change a theorem or whatever. But this paper looks like he asked a large language model to rewrite it from scratch. Like I don't see a lot of the same. I mean, you see some similarities, but it's so different. Um, yeah, it's just weird. Like this looks different. It doesn't have the same thing. This is the main theorem now. It's not even the same number. It's not on the same page. Not even close to the same page. The this is different. Um, what is going on here? So the unconditional spacetime Penrose inequality now, um, they kind of give a further definition here. And then again, it says any closed trap surface. So now it doesn't have to be outermost, doesn't have to be stable. Like this again is clearly wrong. We know this is wrong. Um, and I don't even need to go through the rest of this. And then it gives a further statement that says, even if the dominant energy condition isn't satisfied, there's a defect. I mean, I wouldn't be surprised if there's some defect in equality, but I don't believe any of this, so I'm not even going to get into the details. Yeah, 445 pages. This is nuts. Again, lots of bullet points all over the place, lots of markers of a large language model that none of us is going to believe this garbage. It's nonsense, yeah. And I don't even want to look through all the again, you see lots of bullet points, and I just want to go to the end because it is interesting now. It did increase the number of citations, and it did cite our paper. I'm partly pointing out this paper because it is more recent. So if someone was to forget a paper, it might be ours because how recent it was. But it is now, it's updated itself. I really think this person just had the large language model produce a completely new paper. It didn't seem to ask it to massage the paper from before. It just seemed to ask it to completely generate a new one. Because I didn't look too carefully, but I don't even see the same images and stuff. Um, though this image does look similar. So anyway, I don't even want to get into that. It's garbage. We know it's garbage. And then, but the other thing that's kind of disheartening is that they posted another paper on December 7th proving something else called the angular momentum Penrose inequality. Um, Again, I'm not as familiar with this one because I don't get into when you go beyond when you start adding angular momentum, it is very interesting stuff, but it gets more general relativity heavy, and I generally stay away. But my collaborator does work on this kind of thing. My collaborator Marcus Curry on the other paper does work on this kind of thing, and it does look like again in the same spirit. I'm sure there's mistakes. I'm sure this is not correct, but I don't want to go through the details. The difference with this one though is it's a reasonable length. Now it's well again, it has way too many bullet points again. But now it's a reasonable length. I think this is 31 pages total. So it's like this is what I expect from a research paper length. But again, there's just so many um whoa, this is interesting. So there's so many bullet points. Okay, the acknowledgments are interesting. The author likes to thank Marcus Curry. Now, Marcus Curry is my collaborator who I met with last Friday, who actually showed us this paper. So I'm fairly certain this person does not know him because he doesn't know this art guy. And Sergio Dane is unfortunately now dead. He died fortunately not super recently, but he's not alive anymore. I mean, of course, it's somebody you could acknowledge because he worked in this area. Um, I don't believe this acknowledgement. Now, hold on. I want to go back to this other paper and look at its acknowledgments. I forgot it had acknowledgments too. Um, let's see what they acknowledged here. Okay, this is interesting. So the acknowledgement thanks the referee for their careful reading. Now, that's something that we do, but we only do it after it's been refereed. Like, so when you first post something to archive, it's usually not been refereed yet. And then again, it could take months to a year to years to get refereed. And then sometimes when a referee referees my paper, they find something like a mistake. And I'm very grateful that they did, or maybe they just provided like some really good feedback, like above and beyond what a referee tends to do. And I might, in my acknowledgments, like mention that referee. You can't mention them by name because you don't know who they are. So this is a thing that we do. It's also the kind of thing that a large language model would just copy from other papers, right? So this looks like to me like the large language model just copied this, because it saw a lot of other papers doing that. Because it doesn't make sense for this paper to thank a referee, because I'm fairly certain it has not been refereed yet, because I know this paper would not get refereed kindly. There seems to be another acknowledgement. There seems to be two of them. This is weird. There's like double acknowledgement sections, but anyway, that's just a weird mistake. Okay, let's move on from these details because this is clearly not correct. It's clearly generated by a large language model, and it's not worth sticking around for too much longer here. Though it is interesting that this, yeah. Anyway, so what are we to make of this? What are we to make of this? Well, first of all, what we're not worried about with this paper is not going to get published. Okay, it's already very clear to me and other people in my area. Not just my collaborators, but all the other people, other people in my area, I think already know that this is wrong. So it was like within hours that people knew this was wrong. So there's no harm here in some paper getting published, which is incorrect. Okay. Of course, we don't even want this thing to get refereed because it's so wrong, it's so cumbersome to read it that it shouldn't even get to the referee process, but it might, right? Hopefully it gets rejected quickly. All right, what am I worried about with this though instead? I'm not worried about it getting published, but what I am worried about is the AI, possibly, bad actors or whoever this person is. Maybe they're some amateur mathematician who really thinks that they're solving this problem, or maybe they're just someone who wants to like mess with our community, wants to see if they can get some garbage paper through. Like maybe they're just trying to like test us somehow. I have no idea. But they're not going to be successful as far as I can tell because they're not producing good, even AI stuff. Like, for instance, it would have been pretty easy just to make the theorem a correct statement because you can just copy it from our paper when we put the conjecture of the correct statement. And you could have easily fixed the diagrams, right? And you can ask the AI to use less bullet points or something. So what am I worried about? I'm worried about is a bad actor who does an even better job, maybe. But actually, another thing I'm worried about is just flooding the zone with garbage papers, right? That seems more worrisome to me because it doesn't take you much time to ask a large language model. Maybe especially if you pay for like the most recent large language model version that's strong, it doesn't take long to ask it to produce a 200-page paper proving whatever you want it to prove, and then post it to archive. So what's more worrisome to me is, bad actors just flooding the zone with garbage papers, right? So to the point where there's more garbage papers than there are good papers. Like we're already worried about people, like humans, posting way too many papers to archive, but the amount of time it takes even a person to publish to post, maybe not the best quality papers is still nowhere near the capacity of just someone producing garbage using AI. And again, especially if that person does some kind of pre-processing to make it less difficult to tell that it's garbage, right? So that's what I'm worried about. Like if this gets even a little bit better, I'm not worried that this AI system is actually going to prove the space-time Penrose inequality. If it did, like I don't know, that'd be interesting. Like I would read that paper if it actually proved the result. We would love to learn the mathematics. Of course, I would feel a little bit worried because it's just the kind of thing that you feel some kind of existential dread or anxiety about. But I would read that paper if it was correct. But I just don't think that's very likely anytime like in the immediate future. It's more likely to get a bunch of garbage papers that are clearly not solving it. But the problem is, as those garbage papers get better, it might be harder for us to tell that they're garbage, right? Maybe the main statements are correct, and maybe the introduction looks reasonable. Now I got to actually dive into the details, and it might take a lot longer for me to find an obvious issue. And maybe, again, I'm not so worried about them actually getting published, but if I have to spend time refereeing a paper that's definitely wrong by the time I get to page 20 over and over and over again, this could cause a lot of problems, just like in causing, just flooding the zone with garbage that now we have to, attempt to referee and waste a lot of time on. And for the most part, when humans post papers, you may not think it should get published, but honestly, you rarely find a huge mistake. I mean, it happens, but it's quite rare in my experience. Most of the time, the papers are correct. You just might think they're not written that well, or you might think they don't deserve to be in the journal that they've been submitted to. But you rarely find like a huge mistake in a human's paper. It just happens every once in a while. Um, but if you flood the zones with papers that have lots of mistakes deep, buried very deep inside, it's going to cause a huge problem. It's going to ruin the community and the culture that we've set up for ourselves, and we're going to have to figure that out. And then more broadly, I'm worried that AI is going to do way more harm than good. I'm not talking about Terminator style things. I'm not worried about that. I mean, that could happen in the future. I don't know. I'm worried about, the next year, 2 years, 5 years, just the constant degrading of information, right? Like, let's go back in a second on a little a thought experiment. There was this naive idea that I had as well that like when the internet, not like beginning of the internet, but let's go back to like 2010 to 2015, there were these thoughts that like the internet and Twitter and social media and things were going to democratize information in a way that was going to be a net positive. And of course, let's be clear, it has caused a lot of positive things. But what I think the naivety there was the following was we thought of knowledge as like this black and white thing that as long as you have the knowledge, you just follow the knowledge where it takes you and you get to truth. And of course, that's just not how it works, right? So we thought, oh, if the knowledge is available to everybody, they'll just follow it and then they'll find the truth. And now more people will have the truth. And isn't that much better? Of course, that's just not how knowledge works. Knowledge involves an incredible network of trust. So I have never done a physics experiment. Oh, sorry, I've done some physics experiments in school, but I've never done most of the physics experiments with any kind of um, accuracy. I just take them for granted that other people have done them. They've been checked by several other people, and they seem reasonable for me to trust it, right? And then chemistry experiments and biology experiments and all this different evidence, like most of it, I've never seen firsthand. I've never even seen secondhand, third hand, right? But I trust these people. And then when it comes to medicine, and then when it comes to politics, and it comes to current events, all kinds of information requires me to trust. And when it comes to like current events in politics, that trust is even harder for me to form, right? Even amongst a person who reads a lot, is fairly well educated, it's not easy to construct a web of belief from the complex information I have to somehow sort through. Because I think the naivety of our prior views on this was we thought that like the more there was information out there, the easier it would be to find the truth. But actually, the counterintuitive thing is the more information there is out there, the more garbage information there is out there. And so it's actually harder to find the truth because I don't know who to trust, right? And some of us may spend a lot of time like cultivating this kind of trust, but if you're the kind of person who's just working a job that has nothing to do with you know this kind of knowledge acquisition ideas, then you just want to know who to trust, right? And anyway, I don't want to get into that too much, but basically what we're seeing now, we've been seeing, is just the fracturing of people into subgroups who have wildly different information because they trust wildly different people. And I don't blame anyone for trusting in this crazy landscape. It's not surprising to me that we're fractured into all these different groups of trust. So what I'm worried about is that being even more degenerated by large language models, because now if you trust a large language model, unfortunately, there's not a good reason to think that you should trust a large language model. I think large language models are extremely useful, but you have to have the critical thinking skills and the ability to know when not to trust it, and you need to know when to be skeptical with it. So it seems like to me, to give a more positive spin, we need to teach ourselves and we need to teach people how to be even more skeptical. But the problem with skepticism is the more skeptical you are, the less beliefs you will form, because you can lower your level of trust because you're worried that there's just more garbage information out there. But the lower you level, the lower you bring your trust level, the less beliefs you will form. And again, I think that unfortunately is what we need to do in this environment. But that means the less knowledge you will form, the less knowledge you will believe in, and that comes with its own problems. But I think unfortunately, that's kind of what we have to do. And I don't want to give too definitive of an answer right now because honestly, I'm still on the phase of wondering what the heck's going on here. Let me end the video now because now I'm just kind of, thinking wildly. But I am interested, what do you think? I hope you learned something about, math research papers and how they're posted. And I thought it was just important to call out this paper because it's obviously wrong and it's obviously produced by a large language model of some kind, and we want to make sure that we get ahead of this and we need to think about what we need to do about this. So please like, comment, and subscribe. Let me know what you think, and I hope to see you at another video.